Then you'll see what's going on. I want you to know kind of behind the scenes what's happening. So we're not ready to graph polynomial functions yet, but what we are going to do right now in the moment is start finding what we call zeros. And the zeros of a polynomial function at this point, it's perfectly sufficient for us to think of it like this. The zeros are the places where the graph crosses the x-axis. So I've circled them for you. So I'm going to trust Honor System that you guys will not use Desmos for this assignment. Um, because honestly, I just want to be fully open about this. I like to kind of get in the way of these things. There is nothing stopping you from just doing the entire assignment, the next Delta Math assignment, by just going to Desmos, typing in the function, just like I did over on the left, and then getting the answers off the computer. So I just want to make sure you're aware that I'm aware of that possibility. And you're not going to do that. You shouldn't do that. That will rob you of your ability to learn the algebra that we will be required to use in the lesson after this one. Okay. Could I check my answers using technology? I suppose. But really, the lesson I'm going to give you, what I'm going to show you is how do I find those purple things without letting a computer graph the curve and then I just look at it and go boom, boom, boom. And this will be imperative when the answers are no longer things like -5, -2, and -1. Like, what are we going to do then if the answer is like -4 plus or minus 3 root 6 over 2, and then the other one is like -3/7? Like, holy smokes, we're going to be in a bit of a pickle. So, full disclosure, it is possible to do dishonest things. Don't do it. But what the mission will be now for the next 10, 15 minutes is how do I find those purple points if all I'm given is the function and not someone to graph it for me? Okay. So all of the problems you're going to see in this next assignment are what we call cubic polynomials, meaning that they will all have x to the power of 3. You can see that right there. So they're all going to be cubic polynomials, and we're going to find all of the zeros manually using algebra, using math, not using a graphing utility. I'm not going to say that Desmos is not awesome because, oh boy, is it ever. It's like the greatest thing ever, but this is not the day. These next couple days are not the days for us to be thinking in those terms. Okay. Do you understand the mission? We're going to find the purple things and we're going to do it by hand. So let's go ahead and in your notes, why don't you real quick copy down this function? So you're going to write it as like this. You're going to write f of x equals. That's going to be the notation that we use you remember this from algebra. That's how we designate a function. So it'll be a function named f. It's a function of x. X is the play around variable, right? And the function is defined as what you see on the TV. I'll write it again for you. X cubed plus 9x squared plus 20x plus 12. Everybody got that? I'm going to switch screens in just a second. Would you guys please, before I switch screens, someone write down these three numbers, the -5, the -2, and the -1. I know -1's not labeled, but it's halfway between 0 and -2, so that's a no-brainer. Do you guys have everything jotted so I can switch onto the writing board?
Yeah.
Okay, let's do it. So the function, this is what your assignment's going to look like. You're going to be given the function. I just need to rewrite it. Apologies for wasting your time here. And you're going to be given one piece of information. This is going to be the key. And eventually, I'm going to teach you something called the rational root theorem. That's a week at least away, where we're not going to need the freebie. But throughout this assignment, the computer is going to give you one freebie. And the freebie is going to look one of two different ways. And I'm going to go back and forth throughout this lesson so you can see the different ways that it comes at you. But could someone read me one of the purple numbers? Any one of them is fine. Oh, okay, that went well. Thank you. -5 is fine. So the fact that the graph crosses through the x-axis at -5 means this. It means that x plus 5 is a factor. And I'm going to need you to write that down. For the record, if Landon had said -1, I would have written x plus 1 as a factor. If he'd read me the -2, I would have said x plus 2 is a factor. Notice I'm doing the opposite because when he said -5, I had to build a divisor, a factor. You'd remember this from our synthetic lesson yesterday, that I need a factor that represents, I need it to equal 0. So when he said -5, I knew I had to put -5 plus 5, x plus 5. Got it? So this is what your problems are going to look like throughout your assignment. Now, what we're going to do is we're going to ask ourselves, okay, fine. So the computer gave me one answer. The computer, when it says this, is effectively giving me one of my three answers. X has to equal -5. The question is, how do I find the other two? And that's where synthetic division comes to the rescue. So we're going to do what we learned yesterday. We're going to take the numbers off of this polynomial, and we're going to synthetically substitute -5. So we're taking yesterday's lesson, and don't worry, you'll have lots of time to work on yesterday's lesson too. But we're taking the mechanical skill that we learned yesterday and applying it to a much, much, much greater purpose, mathematically speaking. So we're going to set up our synthetic template. We're going to do 1, 9, 20, and 12. We're going to upside down divide it like this. And we are going to put -5 out here. And the reason we're using -5 is because the computer told us that -5 would work. Here's a question. The fact that -5 is going to work, what does that mean is going to be in this yellow box? If it works, you may not know what that means yet, but what do you think the remainder is going to be? 0 is good job following your gut instincts there. Whenever a remainder is 0, that means that the divisor we've chosen to use is a factor. It cleanly should divide with no remainder. Okay, so let's go through the process. It might be a little presumptuous of me to put the 0 there early, but it's a nice target. It's a nice reminder for myself to say, I know what I'm shooting for. Like the computer told me this would work, so it's probably going to give me a 0. So let's dive in. What's step 1 that we learned yesterday? Drop your 1 and the algorithm begins. Multiply, add, multiply, add, multiply, add. You just repeat, repeat, repeat. What's -5 times 1? What's 9 plus -5? What's -5 times 4? -20. And what's 20 minus, well, this did not work at all. What happened here?
That's what I was thinking.
Well, I got to go back and look at this. Did I copy this down wrong? What had 1, -5, 4, -20? That's a 0. Okay, yeah, I got to go look at this graph again. Did I? X cubed plus 9x squared plus 20x plus 12. Is that a negative? Oh, that's a -6. Look, oh my gosh, I'm embarrassed. Here I was making fun of the graph and I covered, oh, I got to go back. Okay, well, I'm glad I'm recording this. I never mind my buffoonery. Does everyone see that that's actually a -6 and not a -5?
Yep.
My bad. So we have to go back to the other board, and now that I am not being a bonehead, we can clearly see that this should not say x plus 5, but rather it should say x plus 6, of course. And what does that mean is the number that we'll be testing? Not -5, but rather -6. Apologies for that. I should be better than that. But I guess it's good to watch your teachers make mistakes. Remind you that we're all in this together. So let's try it now. And if this one doesn't work, I'm probably just going to take the rest of the day off. If it's all the same to you. So yeah, we're going to drop the 1. Let's try this again. What's -6 times 1? -6. 9 minus 6 is 3. -6 times 3. -18. 20 plus -18. 2. Thank you. -6 times 2. And there is what we expected. So you'll experience that. I did not do that. Sometimes I mess up on purpose, but that was not on purpose. But you will experience that sort of failure next week when we start going in a little bit more blindly and we start just testing numbers out of hopefulness. But that one should not have been a failure. So there you go. So the verification has occurred, and you might say, okay, so what do I do now? I pat myself on the back and say, well, I already knew -6 was going to work. What we're going to do is we're going to put our mad factoring skills to use to go track down the other ones. And the other ones are going to come from these three numbers that I've underlined in red. You know from yesterday how to write those three numbers. What are they? What do they represent? Remember the problem started as x to the third. So what is this one going to be? 1x to the second. And what's the 3 going to be? Plus 3x. And what's the 2 going to be? Plus 2. So what we're going to do, and this should be extremely light work for you guys, is we're going to factor that white quadratic trinomial at the bottom of the screen. And that is nothing, right? That's super light work for us. We know to build two shells because it's just a simple basic quadratic. We're going to put in our x's. What are the signs going to be? Plus and plus, and what are the numbers? 1 and 2, right? There's zero chance that you would look at that and go, I don't know that, like we did that 1,000 times. So now what we're going to do is we're going to get our other two zeros from these parentheses. What makes the purple one equal 0? X equals -1. Not minus, but x literally has to equal the number -1. What makes this green one equal 0? X equals -2. And then the one we had earlier that your teacher clearly was too dumb to consider was x equals -6. You will get three answers for these because they are cubic polynomials. The fundamental theorem of algebra states that if you got a third degree function, you're going to find three answers. As high as the degree of the polynomial is, that's how many answers you're going to get. So aside from the fact that that was a bit bumpy and messy, that's the process, okay? I apologize. This is all part of the trying to buy a house thing. My bad. Got it? All right, so let's do another one now. And this one should go quicker, I hope. So we're going to do f of x equals x cubed minus 3 x squared minus 22x plus 24. And this time I'm going to tell you that x minus 6 is a factor. So this time we're going in blind. We have no graph to help us pick out little purple dots on a screen that a computer did. We're not completely blind. I shouldn't say it like that, but we're going to first set up the synthetic division. So we're going to take our numbers, the purple numbers, boom, 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 boom. And you won't find any trickery with this assignment. The assignment before it, you're going to remember the trickery where you have to put in some extra zeros sometimes. These are just going to be straight droppers. 1, -3, -22, +24, upside down division. And what will be our tester number? You guys are a quick study. Good job. If the factor is x minus 6, then the number that works is +6. And again, I don't consider it presumptuous at this point for you to put a 0 there and just put your foot down and say, unless someone's lying to me, then this should work. So we're going to go through the process, drop the 1. 6 times 1 is 6. What's -3 plus 6? What's 6 times 3? What's -22 plus 18? -4. And then what's 6 times -4? And there's the 0. So if the information you receive is true, then you can expect that 0. And now what you're going to do is you're going to use your factoring skills to take these three resultant numbers and create a quadratic. A cubic will always drop to a quadratic when you smack it with one layer of synthetic. So this is 1x squared plus 3x minus 4, and we're going to factor that down. What are the factors? Well, we know they look like this. What are the signs? One of each. And what are the numbers? In that order?
No.
Yes, in that order. Okay. And my heart goes out to you if you're still lost on how to factor, but of course, I'll just show you a quick recap. Remember, those make -1x, those make +4x, right? So it works. And so we have to ask ourselves now, what answers or zeros are we getting from these? Well, what do we get from this one? X equals not -4. X equals -4. Okay, stop saying plus and minus. X equals an answer. X equals. We're finding answers. How about this yellow one? What makes him happy? X equals 1. And then, of course, we always have the freebie from the beginning of the problem, and X would equal 6. Okay, so those are the places where if we graphed that, we would see the graph swoop and cut through the x-axis at those various points. All right, let's go again, round 3. Let's do f of x is equal to x cubed plus 4x squared minus 11x minus 30. This time I'm going to change my verbiage, and delta math is going to change back and forth and back and forth. And so one problem, you'll see something like x plus blah, blah, blah is a factor. And then the next problem, you'll see the verbiage like this, f of -2 equals 0. What this means this time is that the graph will cross the x-axis at -2. You don't have to do any opposite stuff or make something equal 0. When someone tells you that f of something is equal to 0, this number that I'm putting a red box around, that's your guy. It's literally what you want to use. Okay? So the freebie is coming at you again. It's just coming at you with a different set of words. So once again, let's drop our purple numbers down. Boom, 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 boom. They are 1, 4, -11, and -30. And then we're going to set up our synthetic. And what number are we going to put on the outside? Straight up -2. Remember, in this case, it's just given to you. And feel free for now to put the 0, knowing that that's what you expect. And honestly, that mistake I made 7 minutes ago turned out to be kind of useful in that, like, just to want a 0, then you got to go back and go, what did I do wrong? So worked out okay. Drop the 1, multiply, add, multiply, add. What's -2 times 1? -2. Add those together. Multiply, what do you get? Add, what do you get? Multiply, +30. And again, as expected, we got our 0. And what's going to happen is those 3 numbers, the purpose of doing synthetic division like this is because it allows us, I call it chipping away at the stone. Like you chip off a little bit to reveal more, and then you chip off a little more. And eventually we'll be doing synthetic on like 6th degree functions where we'll synthetically chip and then synthetically chip again and then chip again. And we always chip, chip, chip until we get down to this zone. And what's so sweet about that yellow oval is that it's got 3 numbers, and 3 numbers will always make a quadratic. So we're going to have our x squared, our plus 2x, and our minus 15. And let's factor. What does that factor down into? Take that. What are the signs?
Plus and minus
Each. I'll take that.
5 and 3.
In that order?
Yeah.
Yes. Listen, I elected today when I assigned the problems to choose what we call level 1. It's not really called that, but it's the computer designated level 1, meaning everything you get, like my yellow numbers, are going to be factorable. Okay, level 2, I elected to not try to force into the lesson today. In level 2, we're going to have to use like the quadratic formula sometimes. You guys remember the quadratic formula? So we're going to get things like x squared plus 3x minus 8, where we suddenly realize, oh, snap, I can't factor it. And that's where my zeros are not going to be pretty numbers. They're going to be ugly. But in this assignment, expect all your answers to be warm and fuzzy and fluffy like this. So moral of the story, if the yellow thing is not factorable for today, for tomorrow, for Thursday, you done messed up. Okay? What then are all 3 of my answers? Let's list them out side by side. What's the first one? I'll take -5. Give me another one. I'll take another one. That is correct. Okay, and the way Delta is going to have you do this, let me see if I can. I think I have it up and running. Yeah, sorry about that. Is that a little too much for you there, buddy? Super bright. So you'll see here, I had a choice to synthetic division to find zeros, level one or level two. Level one's going to look like this. And so all you're going to do is you're going to type in the zeros and you're going to separate them with commas. So like if my answers were like two and then I hit comma and -3, comma and four, then I can submit. This one is, of course, going to be wrong because one of the answers is obviously eight. I was just showing you that that's how you're going to type in your answers, okay? And if you don't like using commas, if you like were born under some weird zodiac sign where commas cause you to freak out, then you can always use this little plus button right over here that makes new boxes like boop, 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 boop. You keep clicking it, you get new boxes, and you can make them go away too. I feel like that's probably enough examples, but you guys can tell me. I have two more queued up, but if you don't need them, then where are you at? You good?
More.
10-4. All right, so you're going to use your last 20 minutes to work. You may work on assignment 8 first, and then you may jump on to assignment 9. There will be more added on when Mr. Rams is here tomorrow and Thursday, but for now, I don't really care which of the assignments. I feel like 8 makes more sense just to really master that synthetic algorithm, get that up to 100%, and then do 9. But you're big kids. You decide.
Yeah, yeah. Yeah.